if we go back to the elementary school example. Okay. And so in that case, our intercept would be how tall do we predict a student to be if the student is 0 years old. Okay. In that case, it doesn't really quite make sense. Well, I mean, I guess 0 would be when the child is immediately born. So I guess there might be a age of 0. Okay. But in other cases, maybe we were trying to predict someone's weight based on their height. Okay. And we might say we want to predict how much do we think someone weighs if they're 6 feet tall. In that case, the intercept, whatever it is, would be our prediction for someone's weight if their height was 0. Okay? But no one can have a height of 0. Right? Even children who are born, their height is not 0. Okay? You can't have a height of 0. That would be that. Okay. All right. Interpretations of the slope, interpretations of the intercept. Are we okay with these? Okay. If you're given an equation and I give you a value, can you make a prediction? Okay.
So when would you have a no intercept? If it doesn't make sense, why would you have it?
So there will always be an intercept. Okay. Because the equation now is always going to be y hat is equal to some value, this is the intercept, plus the slope times x. Okay, so there's always going to be an intercept. There might not be a valid interpretation, but it's still something that we have to include. Okay. So the intercept results from, when we create our prediction run. Let me explain something called a residual. So these are our predictions, but our predictions aren't necessarily going to be perfect. Okay? So when we're talking about, predicting a student's height based on their age, we know that height is determined by many factors. Okay? One of them being age, but many other factors go into it. So there's always going to be a difference between what we predict and what actually happens. Okay? Even for looking at a book, okay? If we're trying to predict how thick the book is based on how many pages are in it. Okay? But there's all sorts of things that go into determining the thickness of a book. Okay? The individual page thickness, right? Some books have thick pages. Other books have thin pages. How thick the covers are, okay? These all play into how thick an actual book is. So let's say we do have a book that has 201 pages. So if a book has 201 pages, we predict that its thickness is 13.5766 millimeters. Okay. What if we take out our ruler and we measure the book, okay? And it turns out that the book is actually only 12.2 millimeters thick. Okay, so according to our previous example, our prediction, and that's the key part, okay, is that this is not the truth, it's just our prediction, okay? Our predictions aren't always going to be 100% accurate. So our prediction for a book that has 201 pages is 13.5766 millimeters. Okay. let's say we actually, we take a real book, so we actually have a book. Book with 201 pages. We measure it. And it is 12.2 millimeters thick. So this is the actual measurement. I'm going to write actual Y. The actual value of its thickness is 12.2 millimeters. So the difference between the actual value and the prediction, this is known as the residual. So the residual is always equal to the actual value minus our prediction. So is our prediction too big or too small? Too big. Our prediction was larger than what it actually was. Okay. And so do we have a positive residual or a negative residual?
Negative.
We have a negative residual because if we do the actual minus the prediction, we have 12.2 minus 13.5766, and if you punch that into your calculator, or if you just do it, you get negative 1.3766. Okay, this is our residual. This is the difference between our prediction and what actually was. Okay. If we have large residuals, then that would be an indication that our predictions aren't very good. If our residuals are consistently small, then that means our predictions are pretty good. Okay? And that all comes into play with that value R, correlation. Okay, so correlation tells us about the strength of a relationship and how good our predictions will be. Okay? You see that when we measure our residuals. Okay. If you take the value R and you square it, okay? So R can always be between what? -1 and +1. If we square R, R squared will always be between what? 0 and 1, okay? Because it's not going to be larger than 1, because anything less than 1 when you square it gets smaller. So R squared, so this actually, it turns into big R squared, and we call this the coefficient of determination. It's just a fancy name. Coefficient coefficient of determination is always going to be between 0 and 100. Or I'm sorry, 0 and 1, sorry. 0 and 1, or 0 and 100%. A lot of times we will change it into a percentage. Okay. The coefficient of determination, this tells us how much of the variation in Y is explained by X. Okay? How much of the variation in Y is explained by X? So you can think of it as 0 to 1 or 0 to 100%, okay? Same idea, 0% to 100%. So when we're talking about the height of a student, okay? When we go to an elementary school and we look at the heights of students, we know that there's a whole bunch of different factors that play into how tall is a student. Okay? Genetics, gender, nutrition, and age. Okay, age is one of those things. Okay? If we had to quantify what percentage of a student's height is determined by age, that would come down to the R-squared value. Okay? So maybe it turns out R-squared is 45%. Okay? So that means the student's age tells us about 45% about his height. Okay? But that other 55% comes from all of those other things, the genetics and the nutrition and the gender and all of those other things that play into someone's height. Okay? Maybe we do this study of a book's thickness, okay? And we find that R-squared is 80%, okay? Well, that tells us that, when we look at different books and how thick they are, knowing how many pages are in the book will tell us about 80% of how thick the book is. But some books are still you can have two books that both have exactly the same number of pages, but one book might be thicker than the other, okay? That other part is explained by the other aspects. The thickness of the pages, thickness of the cover, etc., 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 okay? So the R-squared tells us how much of y, or how much of the variation of y, is explained by x. Is that concept okay? All right. There's one aspect that I kind of skipped over, and I'll do this quickly. But you'll have a couple exercises in your homework, and I think it's rather straightforward enough. And it's just how do we determine the value of the slope and the value of the intercept, okay? So I'm going to just do this relatively quickly, but I think it's straightforward enough that with one or two problems in the homework, you can do it, okay? So determining the value of the slope and the intercept, okay? Okay? To get the slope and the intercept, there are 5 numbers that you need from your data, okay? There are 5 values you need from your data. You need these 5 values. If you don't have these values, you can't get the slope and the intercept. Okay? You need to know x bar. X bar is the mean of x. You need to know y bar, the mean of y. Okay? You guys know those values, right? You need to know the standard deviation of the x variable. You need to know the standard deviation of y. Okay? So this will have to be provided to you in the data, okay, or from the data. And then you need to know the correlation. Okay? So you'll have these 5 numbers, and to get the slope and the intercept, all you do is you take these numbers and you plug them into the formula. Okay? The slope B, and you take R times SY over SX. Okay, so you take 3 of these numbers, standard deviation of Y, standard deviation of X, and the correlation, and you plug it into this formula to get your slope. Your slope can be positive or negative. Okay. Once you have your slope, you can get your intercept. The intercept is A, and that's equal to y bar minus B, the slope, times x bar. So this means you have to calculate the slope first, and you're going to use that value here. Okay, so calculate slope first. And plug it in here. We don't have time to do an example today, but you have a couple examples in your homework that ask you to do this exactly. And I think it's rather straightforward. The hardest part is properly labeling these 5 values, okay? But if you properly label these 5 values, the mean of x, the mean of y, standard deviation of x, standard deviation of y, and the correlation, it's just a matter of plugging them into the formula and calculating a value. Okay? Alright, thanks very much. We'll see you guys next week.